GR IAS Academy.
"100 years, 100 teams, one goal, UPSC Prelims." Hello everyone, welcome back to Mission Surya. This program deals with current affairs completely from prelims perspective. So let's get started. So today we are going to deal with quantum technology, which is one of the most emerging technologies right now in the world. So why it is in news? So 2025 marks 100 years of quantum mechanics, and also Nobel Prize has been awarded in this field. And one more reason is UN has declared 2025 as quantum year. So let's deal our first topic, quantum technology and quantum tunneling. So Nobel Prize has been awarded for macroscopic quantum tunneling in the year 2025. So till now scientists have believed that microscopic quantum tunneling is only available. That means quantum tunneling occurs only in the small particles like electrons. But right now scientists have discovered that even macroscopic tunneling exists. What is macroscopic quantum tunneling? That means quantum tunneling occurs even in the macroscopic particles, that means which are visible for us, and so that is why they have been awarded 2025 Nobel Prize. So these are the scientists who got awarded: John Clark, Michel Devoret and John Martinez. So now let's see our next topic, 100 years of quantum mechanics. So what is quantum mechanics? It is a fundamental branch of mechanics. So okay, we are telling it as fundamental branch of mechanics. So what does it deal with? It deals with the matter like atomic particles and subatomic particles. So okay, we are telling separate quantum physics. So how it is different from classical physics? So in classical physics we are getting deterministic values, but in quantum mechanics we will be getting probabilistic values. So probabilistic values. So next let us see this quantum mechanics will be going forward to give us quantum technology. So what is quantum technology? So quantum technology is the technology where it uses quantum principles of quantum mechanisms. Okay? Why it uses? For achieving capabilities beyond classical limits like computing, communication, sensing and metrology. Okay? However, there is difference between classical mechanics and quantum mechanics. So let's understand it clearly by using quantum computers and classical computers. So what is classical computers? You know, right? Classical computer uses bits. So bit can take values either 0 or 1. You have to note it down. It will take either 0 or 1. And sequential processing. Sequential processing is nothing but, consider a book wherein if it has to read the book, classical computer reads page by page. Now let's see what is quantum computer. Quantum computer unit is qubit, and we already discussed that it is probabilistic. So it can be 0 and 1. That means at any point of time it can have two values, 0 and 1. So the main difference is here 0 or 1. Only one value can exist at a point of time, but here 0 and 1. So in a book, when it has to read, it can read many pages at once. So this is called parallel processing. Okay. Now let's see what are the fundamental principles of quantum technology. So this, just now we have seen, it can have two values at once. So this is possible because of certain principles of quantum technology. So let's see our first principle, that is superposition. So let us consider a coin. So what does a coin do? When it is on the table, it either shows head or it either shows tail. But when you toss the coin, it will be in the air, right? So that time it can be anything. So now it is having two states, head and tail both. So this is the example of our quantum technology and superposition. So in the same way, qubits can be represented as 0 and 1 simultaneously. So this allows us to have many solutions at once. Okay. Now the next principle we are dealing with about quantum technology is entanglement. So this is very surprising thing. Okay. Scientists can use this to determine one value of particle A by knowing another value of particle B. So how it is possible? This is possible because of entanglement that is present in the quantum technology. So what is entanglement? So if you notice here, let us consider this as particle A and this is particle B. If you notice here, these two particles are connected. And how far they are getting connected? Let's say if it is in the earth and let's say if it is in space. Even though there is so much of distance here, still if we know the value of particle A, we can know the value of particle B. So this is possible because of entanglement. So this entanglement is nothing but two or more particles are quantum linked. So this is the meaning that if we know one value of one particle, that we can determine the value of another particle. So what happens because of this? If one particle value changes, instantaneously it affects the other regardless of distance, whether particle A is on earth and particle B is on space. So this has been termed as spooky action at a distance by Einstein. Okay. So now let's move to our next principle of quantum technology, which is called as interference. So what is interference? So if you notice here, you are seeing two waves. So what does it mean to you? That means quantum technology works like a wave. Quantum particles works like a wave. So if particle A, particle B are aligning, so it is increasing the existing condition. Okay, so it is increasing the existing condition. And if you notice here, one having crest and the other is having trough in the wave. So what is happening? The resultant wave is in between like this. So this is called constructing interference and this is called disruptive interference. So what does constructive interference do? It amplifies the current outcomes. And what does destructive outcomes do? It cancels incorrect paths. So this is the another principle of quantum technology. So now let's move to our next principle called quantum teleportation. So you might be thinking about science fiction movies when you heard about teleportation. So what usually happens over there? People travel, time travel, right? But here we are not moving the particle from one place to another place. we are just changing its state from one place to another place. So that is called quantum teleportation. So we are just transferring the unknown quantum state from one location to another without moving the particle itself. So it is important for us to note that particle is not being transferred from location A to location B, only the state of the particle has been transported, and that is called quantum teleportation. So for this to occur, we are using quantum entanglement. So obviously if you use quantum entanglement, if you change the value of A, then obviously it is going to change the value of B. So that's how you are using quantum entanglement. And you will be using classical communication. Classical communication is nothing but you have to send the information directly, not with the help of quantum technology. So now let's see another principle of quantum technology called observation and decoherence. So observation is measurement of quantum particle. So until you measure, it will be showing two values or more values. That means a quantum particle has many possibilities, but when it is being measured, it will stick to certain state. So observation is nothing but measurement. So it will attain a definite classical state when measured. And the next one is decoherence. So even though it is having so much of possibilities, it is also very fragile. So whenever there are changes in environment, it affects this quantum particles. So how it affects? Whether it is heat or electromagnetic radiation, it will destroy our quantum properties. So our major obstacle in building stable quantum systems. So now even though it is having so many challenges, it still have various applications. So one of it is cyber security and communication. So what is cyber security and communication? So you know, right, there are many issues for data like army defense data. So those are very confidential. So it is very important to protect the data. So that's when you use quantum communication and quantum key distribution. What is quantum key distribution? So it provides unbreakable encryption. So whenever you are sending information using quantum technology, if someone hacks it, the state will change automatically. So if the quantum state is being changed, so we can know that someone has hacked our information. So that is how quantum communication provides us with the safety of tampering with the information. So that is why it is useful in many confidential applications where data security is important. So using this quantum technology, China has introduced its first communication satellite called Mischius in the year of 2016. So it has applications even in healthcare and pharmaceuticals. The first application is protein folding. So if you have noticed quantum entanglement principle, so one change in a particle can cause change in other particle. So using this technology, we can imitate or use the protein particles to imitate the quantum quantum particles can be used to imitate the protein folding, and we can determine the value of the particles. So even it is used for drug discovery, which is useful to identify some diseases like Alzheimer's and Parkinson's, which is very difficult nowadays. Okay, so there are many other applications in other areas as well, like the disaster management and environment. Let's say quantum sensors and atomic clocks are few applications. So what they will do? They will predict earthquakes even before they occur, and they can even predict tsunamis, droughts. So these atomic clocks and quantum sensors help us to model the climate. So next, they are also useful in the development of superconductors, which is having very high temperature, and quantum dots, QLED displays used in TVs and others, and electronic devices which are energy efficient because they can give you correct values. Okay. Next, we have already discussed that quantum technology is one of the most emerging technology in the world. So India will also do something about that, right? So India also has taken some initiatives. So what is India initiative regarding quantum technology? It has started a mission called National Quantum Mission from 2023 to 2031. So Ministry of Science and Technology is the nodal ministry of quantum technology, and by starting this mission, India becomes the 7th country with a dedicated quantum mission. So for any mission, we know that certain goals or targets will be there. So for us mission, we have one goal to develop qubit quantum computers. So okay, we want to develop quantum computers. We know, right, the measurement of quantum technology is done in qubits. So we want 52,000 qubit capacity of a quantum computer, and we also want satellite based secure quantum communication because China has already developed missions, right? So yeah, in the same way we also want to harness the quantum technology and use it for our advantage. So now India will establish 4 thematic hubs on quantum computing, communication, sensing and metrology, and materials and devices. Other key initiative includes for Indian Army quest programs and indigenous QKD solutions. However, there are many challenges to implement this. So let us see the challenges. Okay. What are the technical challenges to implement quantum computing? The first challenge is scalability. So what is scalability? So qubits we already have seen, like quantum computing uses 0, 1 simultaneously. So these are called qubits. So if we want to maintain hundreds of qubits, it is very difficult to maintain accuracy. So having that many computers, maintaining accuracy is very difficult. Okay, because they also have environment issues as well. Smallest change in environment disturbs quantum behavior. So, and it also requires near absolute zero temperature. That means it goes up to minus 273 Kelvin or 0 degrees centigrade. So even smallest error can destroy our quantum computing capabilities. So all our work will be lost. So even smallest error also affects our computation. And the next challenge is security risk. we know that quantum computers are very powerful, right? So they can so we know that quantum computers are very powerful. So they will disrupt existing classical encryption, which is more important for banking, defense and digital governance. In the area of infrastructure and funding, our India spends only 0.64% of GDP, which is very lower when compared to other countries like US and China. And even private participation is very less in this area. And even there are regulatory gaps. I mean, there are no uniform standards to control what happens in quantum technology. There are no uniform standards even for hardware, okay, even for IPR. So these are all the challenges for us. So in order to use the quantum computing despite these challenges, what we have to do in future? So we have to boost private investment, which is very low, right? We have to give tax incentives so that people will be ready to invest in the quantum technology. Next, we need quantum regulations, IPR, policy framing, skill development. We need to have workforce who have been trained on quantum technologies. They know how to work on those, okay? And then technology should be transferred between different countries. If one person is doing research and achieved something in that, if technology transfer has been done, then it will help us, right? So that is how we can work on quantum technology. So this whole topic we have discussed how it is relevant for UPSC exam. So the first point is qubit. It is the fundamental unit of our quantum computing. Qubit values can be simultaneously 0 and 1. And 2025 has been declared as a quantum year. And QKD is based on laws of quantum mechanics, not computational complexity. So that's all for today. Let us continue our next topic in the upcoming class. Thank you. Follow us on YouTube for more such videos.